Okay, so hello everyone and welcome to the OneClass channel. My name is Donna and I'm a recent master's graduate in the Material Science program from the University of Ontario Institute of Technology, also known as Ontario Tech University. So today we're going to go over some commonly asked questions in chemistry at the high school, college, and university level. So if you needed any help with tutoring or with homework, then check out the links in the description below. So now I'm just going to get started on my set of questions for today. Okay, so question number 1. The voltage generated by the zinc concentration cell is described by this, which is 22 millivolts at 25 degrees Celsius. Calculate the concentration of the zinc 2 plus ion at the cathode. Okay, so let me write down 1. And then I'm also going to try and write down the cell as well. So we have the concentration of one of them. We're looking for the concentration of the other. Okay, so basically, I'm also going to write out the reduction reaction and the oxidation reaction for this cell as well, just so that we're all on the same page. So the reduction reaction happens in the cathode. And basically, this is when your zinc 2 plus is converted to the zinc solid, which is at the 0 oxidation state. And then our oxidation reaction takes place in the anode. And in the oxidation reaction, your zinc is oxidized to zinc 2 plus 2 electrons. So I'm also going to write down like the definition of a galvanic cell. So this converts chemical energy to electrical. And this happens through spontaneous redox reactions. Okay, so now that we know that, I'm also going to write down what was given in the question. So E cell, they said, was equal to 22 millivolts. So I'm going to convert that to volts. So it's going to be 0.022 volts. And this is at 25 degrees Celsius. And then to calculate for E cell, it's going to be the following. Well, this is the equation that we're going to need to calculate the concentration of zinc 2 plus. It's going to be E cell is equal to negative 0.022 0.0591 over N times the log of your concentration of anode over concentration of cathode. Okay, so let's plug in all the values that we know. We know E cell is equal to 0.022 volts. We know the number of electrons in this reaction is 2. So I'm just going to put a 2. And then in terms of concentration, the concentration of our anode, which is the zinc to zinc 2 plus, is the 0.1 molar. And then what we're looking for is the concentration of our cathode, which I'm just going to write down as X. So now I'm just going to solve for X. So just to simplify things, going to be negative 0.745 is equal to the log of 0.1 over X. And then to get rid of log, we're going to do 10 to the power of both sides. And then you end up with 0.1 over X. Let's bring it over here. So then your final answer should be X is equal to 0.556 molar. Let's look at the answer from our junior tutor. Since both electrodes of the same material, this cell is a concentration cell and the standard cell potential will be 0. Yeah, right. Yep. So then the reduction of the half reaction is the zinc 2 plus 2 electrons makes zinc solid. Oxidation half reaction is the zinc solid to zinc 2 plus 2 electrons. The standard cell potential is the E cell is equal to E cathode minus E anode. The measured cell potential is 0.022, and the number of electrons transferred is 2. And then they have the same equation, so this is the Nernst equation, which I forgot to mention. And then they have 0.022 is equal to negative 0.0591 over 2 times log of the concentration of the anode over the cathode. And then they simplified it as well and then got 0.556 moles per liter. So this solution is correct. All right, so let's move on to question number 2. So question 2, which compound matches the IR spectrum? And then they have different compounds from A to F. So basically with IR, each of these different peaks corresponds to certain functional groups in the compound. So I looked up the different IR absorptions of common functional groups in advance, and this is kind of the example of the different locations of all of these different functional groups. So first I'm just going to look at our spectra. we have peaks at around 2,690 inverse centimeters to around like 2,700 inverse centimeters. So let's look at our IR spectra, and you'll see that this corresponds to alkane groups. And in particular, it's not in that table, but basically it's for sp2 CH stretches. You'll also see a characteristic peak at around like 1,700 inverse centimeters. And then let's look at our table. So basically this is due to like carbonyl groups. I'm gonna write. So let's look at all our different options. So let's look at A. There are 2 double bonds. So if we look at the absorptions you expect to see for alkenes, you'll see it's in around like the 1,600 range and also the 3,000 range. And then you can see that that isn't present in our spectra. So let me just write down. So there are no 1,600 peaks for double bonds. So we know that it's not A. So let's look at B. So for aromatic groups, there are peaks at around 1,650 to 2,000. So let's look at our spectra. There are also no peaks whatsoever for these locations. So already, not only can we rule out B, we can also rule out F, since they both have aromatic rings. So looking at C, you'll see that there are alkanes, and they also have sp2 hybridized carbon hydrogen stretch, which is what we're looking for, and it also has the characteristic carboxyl peak at 1,700. So it could be C, but I'm still gonna go over all the different molecules. So with a compound like D, there should be overtone carboxyl groups, but it's not there in the spectra. So we can rule out D. E has an NH group. So let's look at the peak we expect for NH. So you expect to see it at 3,300 to around 3,350 inverse centimeters. So let's look, and you'll see that there is no peak present. So therefore, it is not E as well. Yep, so the compound is C. So let's look at the answer. Peak at 1730 indicates the presence of carbonyl stretch. The peak at 2,976 inverse centimeters indicates the presence of alkyl stretch. They also have the peaks at around 2,800 and 2,700 indicates the presence of CH stretching in the aldehyde group. Therefore, the possible compound which matches the IR spectra is butanal. The structure is as follows. Okay, so we are right, and the solution is correct. Okay, so let's move on. Question number 3. Determine the Vanhoft factor assuming 0% ionization or 100% ionization. And then they also want us to calculate the percent ionization of this acid. So for A, when ionization is 0%, then I is equal to 1. So there's 1 species in solution. And then when ionization is 100%, then that's when I is equal to 2. And you have 2 species in solution. That's just some definitions for part A. And part E wants us to calculate percent ionization. So to do that, I'm just going to write down this equation involving osmotic pressure. So this is equal to IMRT, where M is our concentration in moles per liter, and then R is our constant, which I will write down. T is in temperature. So I'm just going to plug everything into the equation first. So osmotic pressure is 1.22 atm. We're looking for I. Our concentration is this 0.045 moles in 1 liter of solution. Our R constant will be the 0.08206. And the reason for that is because this constant has the units that we need for this equation. And then when you convert 21 degrees Celsius to kelvins, you get 294.15 Kelvin. Okay, so let's cancel out all these units. And then if you solve for I, you end up getting 1.123. So for percent of ionization, I'm going to use this alpha symbol. It is the following equation where I is equal to 1 plus alpha over 1. So since we know I is 1.123, this is equal to 1 plus alpha. And then we get the percent of ionization equal to 0.123 or 12.3%. Let's check out the answer from our junior tutor. So they got let's look at these symbols. So the equation looks right, but they just got like a different value for I. One plus I'm just gonna write out what I did. And I'll also write down what I should be equal to. Okay, so I just wrote out what I did just so that we're all on the same page. I'm not really sure what the tutor did in his work, so I just wrote it out in detail. Okay, so let's look at question number 4. Which gas molecules have the highest average kinetic energy at a given temperature? Okay, so we have HBr, NO2, C2H6, So for kinetic energy, we're going to use this equation just to see what it is. It's going to be 3 over 2 times RT. So basically, since KE is not dependent on molecular weight, then they will all have the same kinetic energy. Okay, so it looks like our junior tutor said the same thing. So solution is correct. I think we have time for one more question. Name the alkene below. Use only EZ designators to indicate stereochemistry. Let's write down this whole molecule. Now I'm just going to circle my parent, which is going to be the longest chain of the most important things. So that is our parent. And you can see these two sticking out will be our substituents. And for Z and E designations, Z is for when you have a double bond, and the two heavier groups are on the same side. And for E is when your two heavier groups are on opposite sides. So if you look at our molecule, you'll see that the two heavier groups are on the same side. And I'm just going to also count out the carbons in our parent. So we have 7 carbons, and carbon 3 is where the double bond is. So I'm also just going to write 3Z, since our heavier groups are on the same side, on carbon 3. And then carbons 2 and 6 both have methyl groups, so I'm going to write 2,6-dimethyl, meaning 2 methyls. And then our parent is this 7 carbon chain, so I'm going to write hept. And then just to specify which carbon has the double bond, I'm going to write 3-ene. So our final answer is 3Z, 2,6-dimethyl hept 3-ene. Oh. So our junior tutor just has a lot of other answers, but I can see our compound right here. And they have just said 2,6-dimethylheptene. I'm also going to put a 3 in front of the Z, just to say where the double bond is. Okay, so this answer was correct. That's all we have time for today. So if you like today's Q&A session and you'd like to be notified of when we do this next, then just click on the subscribe button and notification bell below if you haven't already done so. If you'd like to submit a question of your own, then just check out the links in the description. Don't forget to leave a like and a comment if you like the video, and also share this with all of your friends and classmates if they needed any help with chemistry. So this has been Donna from OneClass, and I hope to see you soon. Bye.